now you may be able to hear me. I'm sorry. You've missed the first 7 seconds in which I said we are possibly live. All right. I'm just. Dear God, lamp. Get. Oh. You know, this lamp crashes more often than my computer does. Annoyingly. And my computer doesn't crash a whole lot, but this lamp crashes for some reason. You push all the buttons and nothing happens. I should really have a look at that. I have 2 of them because I really like them, and only this one has this weird thing where sometimes it just decides to change the brightness and the color temperature just completely on its own. Yeah, it appears that we are live. I'm just having a quick listen. Yes, we are live. How jolly. All right, people. Hi. Today we have a little bit of a special something, I think, because I would like to have a look at the recent debate that happened between PhD Tony and Will Duffy. And the interesting part, because I have things to say about it, because they talk about things that I know a lot about, partially, I might add, partially. Now, I am no geophysicist by no extent. I have never, I believe, had a course on geophysics or geology or something as such. But you shall see, I hope, where my expertise lies. Now, I want to share a Chrome tab, and I would like to share this tab, I believe. Okay. Stuff is happening. All right. Okay, I need to move this window over here. Yes, very nice. Yeah, if you're watching in the chat, feel free to send messages. I will read them as I can. All right. We shall begin now. Now, the whole discussion was about the age of the Earth. So it was completely
Please let me join your guild.
So the whole thing is completely unrelated to TFE or anything like that, which I found slightly irritating that they have that, or that Will has the TFE thing here in the background. I mean, I understand it from a streaming point of view. This is a standard setup, but to someone who doesn't know, it may appear that this is somehow part of the TFE discussion or something like that. So I've
mine, and he taught me when I was like 19.
I've looked into the debate until about the halfway point, I believe,
18 or 20 years old. That if I'm ever going to give a presentation to a large group of people, to design it as if the audience was.
Will at some point said something about carbon dating that I find particularly interesting.
Your position, you've got to take all of the evidence.
I can find it again.
Right? For example, if you've got a polystrate fossil.
Yeah, they're talking about fossils.
I'm sorry, that's the level I'm thinking of. Sorry, mate.
Okay, gotcha.
I'm particularly interested in.
You can get microbial action.
Sorry.
Actually, I do have a data set that pertains to this. More data about the shape of the Earth.
Let me have a look. I'm sorry.
It's coming from
I wanted to, by the way,
because I think it's
have a look
warranted
at
here,
it.
but you are.
I wanted to search out the specific time code, but I failed to do so, unfortunately, because I was trying to get this tablet set up, which my roommate thankfully lent me, because I would like to actually write things down and make a little graph and explain the stuff as soon as I find the damn time that it was.
The age of the sun and the age of the formation of the solar system is very much a constraint on the age of the Earth, and maintaining otherwise is simply dishonest.
I agree.
We can look, for instance, at the we can determine how the Earth was formed. We can determine from the evidence available to us. And again, this is very much like saying, show me a picture.
If you got 5-6 minutes, then maybe we get
how to try to figure out with the evidence
what
it was.
Sorry.
Am I correct, Tony, that geology tells us that limestone forms over very long periods of time?
Because
the entire Grand Canyon, it goes for 100 miles.
The thing is, they started this discussion.
But this is a
yes.
If you look at the
now we're getting there. I think it was more in the beginning.
Can you guys see? Here's a map of where we get them from, and here's a map of sort of what they look like. And you can see a global distribution again. cores that are a million years old by digging in certain places.
Exactly. And this, for example, is delta 18 oxygen, which is really, really interesting because when you look at oxygen, all right, okay, I should maybe get a little back further. We all know, or I hope we all know, the periodic system, right? Oh, by the way, did you have audio on that? Just to be sure. Yeah. Also, share tab audio is on default. That's very good. Okay. So when you want to know something about atoms or about chemistry, you usually look at the periodic table, right? So, oh, wrong screen. There we go. So you have a look at that thing, okay? You get on the periodic table. There are a lot of nice ones, like this one, for example, which is my go-to periodic table if I need to look something up quickly. It has some nice information here at the side that sometimes come in useful. For example, if I want to know the melting point that is here, it tells me the electronegativity. And for me, most importantly, it tells me the weight in units, which I find rather helpful, for example. But just as a basic example, right? And here you can see all of the elements that we know of. And when you are talking about, for example, oxygen, this is oxygen here. Oxygen has 8 protons. This is why it is element number 8. It is here in the 16th column. And the mass, the average mass of all of the oxygen in existence, or so to say, in the natural world that we think is 15.999 units, atomic mass units, used to be called Dalton. But what about the different kinds of oxygen? Because oxygen gets its name from having 8 protons. The nucleus that has 8 protons is called oxygen, but it doesn't speak about neutrons. So, and we roughly have a mass 16. So on average, we have 8 neutrons and 8 protons. So the 8 neutrons because we have 16 minus the 8 protons that we know. And this gives us 8 neutrons. However, nothing in principle denies having more than the amount of neutrons that you want to have, right? So in other words, is there some kind of periodic table for nuclei and not for atoms? And the answer to this question is obviously yes. I'm just getting it up here in the background. Just give me a minute or a second here. Feel free to write something in the chat in the meantime if you want. I know there's only one person watching, and I'm horribly sorry for that. Come on, there we go. So you can have. Oh, no, that's not the right one. This one here, yes. This is the periodic system for nuclear physicists, I think, or for physicists that have stuff to do with atoms and nuclei and things like that. And it looks a lot more complicated. And oh, Professor Phil Bell, what a joy it is to see you here. I'm talking about periodic tables, and I will later be talking about carbon dating. But before that, I need to explain why we do it and stuff like that. How very nice of you to drop in. So the periodic system for nuclei is what we call the isotope table, or the isotope map, as it's sometimes called. And here you have not only on the y-axis here, you have the proton number. So you have hydrogen, helium, lithium, beryllium, boron, carbon, and so on and so on and so on, as we had with the periodic table. But on the x-axis, we also have the number of neutrons in a given nuclei. So you can see here, and all of the black ones are stable, right? Can I select the half-life up here? I don't know. I can. Nah, that's better. Let's stick with that one for now. So this is the decay mode. So how it decays. I mean, half-life is the one that's standard selected, but there is no legend here, which is very annoying. Okay, so let's just say the black ones are, as far as we know, stable. This is the important information that we want to remember. So you can see, for example, there are 2 different kinds of stable hydrogen. Who knew? There is stable hydrogen with 0 neutrons, because a hydrogen atom is really just a proton with an electron. Phil Bell, where did you find that map? This is the best map of its kind, and it's NUDAT. It's from the National something Laboratory. NUDAT. Wait, I'm writing it in the chat. And it is a little. Sometimes it loads for ages. If that happens, just refresh the page. It happens sometimes. But it is the best map for this kind of thing when you're looking it up. I'm currently doing my master's thesis in a isotope science group, and I use this at least every week, sometimes a lot more often. But you have everything you need here. You have the all of the decay values. You have the neutron separation energy. You have the pair gap. You have all of the things that you usually don't need, and you can even look at the energy levels if you click on a nucleus, which is really cool. So if you want to know the energy levels of 18 oxygen, it tells you right down there, and you can even get a list of levels as a separate tab. It opens now. You don't see it. It gives you a list of energy levels and all the kinds of stuff. It's a great website for this purpose. Getting back, I'm sorry. So we have 2 stable nitrogens. Yeah, God, we have 2 stable hydrogens. That's what I wanted to say. And as you can see, one of them is a lot more common. This is what the percentage here means. I mean, you can have it for your lecture on Friday. Oh, you were teaching the exact subject. Oh, I'm sorry. I thought you would this Friday. Well, I should have streamed earlier. I apologize. Either way. We have 2 stable hydrogens, and one of them is a lot more common. This is what the percentage means, right? The percentage kind of says this is how common it is in nature, right? And you go up and you see, for example, that lithium has quite a variable isotope rate. It's not ridiculously small and very abundant anymore. It's a little bit more in the middle. And as you go up, you see a lot more elements like that. For example, you have neon. Neon has almost 10% of an isotope. An isotope is called when it has the same number of protons but a different number of neutrons. So an isotope, or the isotope of the isotopes, the stable isotopes of neon are neon 20, neon 21, and neon 22. Okay. Just so we get the names that I will be using out of the way first. And if you look at oxygen, for example, you can see that there is oxygen with mass 16, oxygen with mass 17, and, for what Tony has brought up here, oxygen with mass 18. Turns out, even though they're the same chemical element and they have extremely similar chemical properties, due to the fact that they have a different mass, actually, they behave a little bit different in nature. For example, this tab has crashed. I apologize. Hang on a second. My system resources are good. My processor is a bit on the edge, but that's to be expected from that old of a computer. Okay, so yeah, okay, there it is. So, and this is what PhD Tony is bringing up here. This up here that's the D18. Usually it's written as a delta. I believe in this figure it is a delta, although this figure is even grainy to me. That's because I'm not on... because the stream is not available in full HD. Oh well. Either way, you can actually see a difference in delta 18 oxygen levels, because, as we have found out, delta 18 oxygen behaves differently than other oxygen in, for example, the rain. When it comes down as water as H2O, the 2 isotopes, oxygen 16 and oxygen 18, behave a little bit differently. And this little bit is enough to, for example, relatively reliably trace the amount of downfall at various continents. You can do that with ground samples from Antarctica, for example. You can figure out how much the downfall was there. I think downfall is the correct word for rain or snow or anything that, yeah, either way, that technically isn't the topic of the discussion here. but as happens with me, I go on tangents a lot. But let's continue.
Think of it at the moment. We only go back that far, and we can see in the ocean core data that it goes back way further than that.
Yeah.
that we've got these glacial cycles going back much longer than the ice sheets were in existence.
That is true.
Down the bottom of this figure, you'll
these kinds of dating, these isotope fractionation events, can also be used for dating glacial events, by the way, because the glacier covers a part of the stones, right? If my gray hand here is the glacier and my normal hand is the ground, depending on where the glacier sits, it gets bombarded by a different amount of cosmic particles. And eventually, you can measure that if that happens for a reasonably long amount of time.
see various black and white phases. These are magnetic reversals. So this black one bruness is
Yeah,
where
that's also
the
true, but that's neither here nor there.
and so on and so forth, and it goes 200.
Sorry,
I might
I'm skipping ahead a bit
stop sharing for a moment
because
in
I want
case
to
Will
find a
has any
specific
responses to
thing.
that.
Yes, I do.
Well,
So
Will
I want
has
to
a
start big picture.
misconception.
By the way, my wife's grandfather, who's passed away, was a mentor of mine, and he taught me
That's
when
nice.
I was like 19 or 20 years old that if I'm ever going to give a presentation to a large group of people, to design it as if the audience was fifth graders. It sounded weird at the
That's
time, but I actually think it was good advice. So I like to
general
start big picture
good
where even like
idea,
my kids
I think.
could
Yeah.
possibly understand it. So Tony, I'm going to respond to what you said. I don't want you to think I'm evading you. I've noticed that science cannot date things that are living,
Which
and
is
science cannot date things accurately that we saw
not
with
accurate.
our own eyes
You
be
can
created.
you can date, for example, you can date trees, living trees. You can do that, and we do that. You can date certain oh god, what are they called? Like shellfish, I believe, from the size of the carcass. I think carcass is the right word. I'm not a biology person, and I'm especially not a biology person in technical terms in English. You can date the I need to look up the word now. I'm sorry. Mussels, yes, mussels. You can date mussels by their shells, for example. So I'm not sure where he's. I mean, I know where he's going because I've watched that part of the debate. He's saying, well, if we can't date live things, how should we date dead things? Which unfortunately shows a major misconception about how dating methods work, I'm afraid. And every time I say dating methods, every single time I think about, like blind dating and speed dating and things like that. No, that's unfortunately not what I'm talking about. I'm one of the least qualified persons to talk about this kind of dating.
Do you see the issue with that when we're going to take a firm stance that science can tell us things that happened millions and billions of years ago?
No. So this is like
Yeah.
like saying my dentist cannot detect cavities in my teeth with an aircraft radar.
That is
Therefore,
correct.
aircraft
That is-
radar is useless
that-
over distances of a
No,
kilometer.
but
It's exactly the same thing.
That is.
Let me try to
You're
elaborate.
saying
I don't
that a
think it's
measurement.
the same thing.
Tony's
No,
correct, yeah.
please, I'm in the middle of speaking. You're saying that a measurement tool doesn't work on small scales, therefore it can't be trusted on large scales. That's exactly the argument you're making, and it's
I agree with Tony too.
it's untrue. It's also untrue that we can't date things that are living. That's absolutely untrue. We know exactly how to do that. You're probably referring to what's called carbon reservoir.
Exactly. And now they talk about. Oh my god. I'm sorry. And now they talk about carbon dating. And the reason that I would like to talk about carbon dating is because I work at one of the world's most. Oh, I don't work there. I do my master's thesis there, but for that I do work there. It is not paid, unfortunately. But I work at one of the world's most capable dating facilities we still have. And that's because we use a particle accelerator to date things. Now, I will be explaining that in some reasonable amount of detail in the stream, I hope. But yeah, not PhD, Tony, Jesus Christ. Professor Phil Bell in the chat here says you can sample anything and investigate the abundance of a particular isotope in that sample. That is correct. You can do that. And if you do that sufficiently, you might find something interesting.
Corrections.
I will talk about that.
No.
You're not?
So no.
What are you referring to?
People, human beings. If I brought you a human being, any random age, you cannot date them.
Not accurately. That is mostly correct. If you know some of their history, you can do that somewhat more accurately. You can do that a little bit with teeth, I believe. You can do so with some. What was it? With somehow measuring the exact contents of their bones. If you do a biopsy, I believe you can make a very educated guess on that person's age, but you only get within plus minus 5 years because this is a difficult process to do. And I'm not sure if Will fully understands that, but of course you have uncertainties with every dating method. You can't date something to the second. For example, when we do carbon-14 measurements at the facility I'm currently at, we can't get much more accurate than a few decades and like 20 or 30 years, but that will be extraordinarily good. Mostly we are like plus minus 50, 60, 70 years. I have only ever done once of them, but yeah. Someone new in the chat. Hello, by the way. Simulacrum says dating methods apply to a narrow set of conditions. Somewhat, yes. Life typically does not have a particular variable that can be isolated and correlated with age. That is correct. Of course, if you knew, for example, that person says every day since I'm 3 or something, I have eaten this and that amount of rice. Maybe you could make some determination by some elemental build-up of this specific rice, but in general you can't, of course, because the age, the body of someone who keeps themselves fit and who exercises is going to look younger, even though they're the same age as someone who maybe can't exercise because they have some problem or something, some medical condition or something like that, and yet they're going to look different age naturally. This is to be expected, right?
There is no method to date them. The only way to date them is to trust the birth certificate or to have
Technically, yeah.
a video of when they were born.
Okay, you've baited and switched. You've said we can't date living organisms, and now you're talking about humans.
Well,
We
humans
can
are
date
living
living
organisms.
organisms.
Technically, that's
Yes,
true. Yeah.
some human organisms
Um,
don't provide systematic
But
layering.
I'm not here to judge on the debate. I think Tony gets a little aggravated very easily, and I honestly don't like that. As does Craig from FTFE. He's not part of this debate, but I think he's very much on the side of truth here, and I think Will has some some misunderstandings. But again, that's neither here nor there.
But actually, we can, for instance, if somebody was alive during the atomic bomb testing, we can certainly detect if they were.
Yes,
we can.
That's really cool,
and that's a character. That's a category error.
Not only can
saying
we,
that
we can date the amount of fallout that there has been from the nuclear bombs by having a look at the copper in the copper roofs of Japanese buildings in the surrounding area, because it turns out that there is some copper isotope. I don't know which one. I can look it up and do that very quickly. There's some copper isotope. Or maybe there isn't. Yeah, there is some copper isotope that lasts for a little bit longer. Oh no, maybe I'm looking it up. It wasn't copper, I think, because the longest lived isotope I can find that is not stable is like 61 hours, which would be very low. I believe there is some though. Was it maybe because it was used in roofing? Just because it was used in roofing, I'm just looking up if I may have confused that with lead. Yeah, there are a couple of lead isotopes that last a couple of years. There is one that lasts 22 years. It may have been that, but something like that. I've given, actually, now that I think about it, I've given a presentation about this topic. Maybe I have the slides. Hang on one second, please, for me. Very happy that you're here, by the way. Yes, that is true. I'm sorry that you have to leave, by the way. It would be very nice to have you sticking around. But yeah, it would. Most people don't believe that radiometric dating. Who do not believe that radiometric dating? Yeah, that because it is very complicated. Most people that don't believe in it don't fully get it, which is unfortunate. I kind of understand it. It is a complicated topic, naturally, right? But yeah. So let me have a look if I can find this thing here really quick. Not here. Oh, it was in the 11th term, maybe, or in the 12th. I have them classified by. No, it certainly wasn't them. It was the one before that, I think. Yes, it was. Yeah, that's true. You can compare uranium mass present to other uranium isotopes. We actually also do that at the facility that I'm at. Yeah, so I'm reading it up right now. Give me 1 second, please. You can use it as oceanic tracers, for example, from the bomb peak. You can do so much stuff with all of that. Beryllium actually correlates with rain. I accused oxygen of that. Apparently, it's beryllium. I confused that. I'm so sorry. You can do astrophysics with that. You can do so many things from that. But annoyingly, I can't find the example that they used from the roofs. Well, that is annoying. And delta oxygen. I'm just reading it. It has something to do with water. It changes when water evaporates because the 18 oxygen gets left behind more frequently than the others. That is what that was about. I remember. Yeah, I can't find it now. I know that they did that though. Yeah, they did that when they had a look at some isotope that left for a couple of years, and from that they determined the amount of radioactive or of ionizing radiation from the nuclear bombs dropped on Japan during the Second World War. Another tangent. I should move on.
Beings are living things, therefore we can't date living things. That's absolutely untrue. Okay, we can date living corals. We do.
Yes, you can
Date living corals. We can date trees.
Sure,
we do date living trees. We can date fish from the little osteolates that accumulate in their ears because they have growth rings. There's plenty of stuff. There's plenty of living stuff that we can very accurately date.
Okay, so hold on a second. I'm just trying to give everybody how my mind works. And so and again, I can drop the humans after I say this part, but we can't even date a baby in the womb, okay? Pregnancy is dated from the woman's last menstrual cycle because there is no accurate way to date and figure out when conception occurred. So my point is, if we struggle to date living things, I think we need to at least have a pause when we're going to be dating things that are millions and billions of years old. That's all. That's the only point I'm trying to make. And I'll tell you something that's in your field. And again, I'm taking your word for the things you're saying. I'm taking the young Earth creationist word for the things they're saying. There is a young Earth creationist PhD geologist who's a fellow Aussie. Okay, his name is Andrew Snelling.
The interesting
and
thing
he
about,
dated,
I mentioned him previously.
About how should I say creationists that are, or young Earth creationists specifically, that are also scientists, is that as soon as it comes to science, they don't write about this topic. They write about something else because they would never make it through peer review. Simulacrum in the chat here says that, Duffy, you have to date everything or you can't date anything. Yeah, no, that seems to be the prevailing motto here, which is a little sad. I applaud Will Duffy. Honestly, just truly, I kind of don't like Will Duffy, and I don't think he has deserved that. But I have a little bit of a with him being like rich from finance, which makes him suspicious to me. I'm sorry, and being or wealthy from finance, let's say that, and which makes him suspicious, and being in a weird way religious in the young Earth creationism thing. But I applaud him for what he did about flat Earth and stuff, right? So, but he doesn't seem to have internalized scientific thinking, I believe, unfortunately. Which again, he's a pastor. He has the privilege not to, right? But yeah,
there's something that was discovered in Australia. It was some sort of petrified wood, and it was both carbon-14 dated and potassium argon dated, and the difference in the dates was wildly different.
Now, I don't know the range for potassium argon dating. I do not know, but I'm sure I can figure that out. What are we talking about in terms of age, typically? Let me have a quick look. Is most applicable for dating minerals or rocks over 100,000 years old. See, and here's your problem. There is your problem right there. You're using the wrong tool for this job. And now I'm afraid I will have to hit you with some quite heavy physics. Heavy, not objectively, but heavy in the context of what you can usually find by someone doing a silly live stream. Can you see? I think you should be able to see my drawing pad. This is my wonderful. This is not my drawing pad, by the way. Again, I will very much like to thank my roommate for lending me hers, because I have for the second time when I want to do a stream, forgotten mine, because mine is still collecting dust somewhere at my parents' place, because that's when I used it the last. And I was there this weekend for something unrelated, and I've completely forgotten to pack it yet again. Okay, people, we would like to date something using radioactivity as the kind of thing. So, what is radioactivity? Simply put, wait, I need to hide this thing. Hide. All right. Simply put, you have some amount of stuff. Let's say you have a lump of gobbledygook, as they say in Scotland, and this stuff of gobbledygook has in it something that is radioactive, right? Sorry, that's my handwriting on a drawing pad I'm not used to. That may get ugly. Yeah. So this thing is radioactive, and now what you do, typically, what you do is you can do that in multiple ways. If you know what it is that you have here, you can wait for a decay, and you can measure how many decays have happened with a detector, right? Detector. That's ugly. Detector. Radioactive decay just means that the nuclei in there, for some reason, let's not get into that, they decay, they turn into something else, into some other nucleus, and usually they emit a particle. They all do that with an decay, but some particles are more easy to measure than others. There's alpha radiation, which are 2 protons and 2 neutrons together. This is called an alpha particle, and this is also technically a helium-4 nucleus, right? You can have electrons. This is beta radiation. There are 2 different types of beta radiation, beta plus and beta minus. Let's not get into that. Just say beta is electrons for our purposes now. And there's gamma radiation, but this gamma radiation usually only occurs after another decay, and that's again neither here nor there. I don't want to confuse you too much. So you have radiation. That's the important point, and you can count it if you know, right? If I give you a lump of something radioactive, you can put it under a counter, and it counts to you how many of these decays it has measured. And if you know how many this thing can measure, like you say it can only measure 80% of any given radiation, you know that, and you know how big the angle was, the room angle. So if it covers half the room, of course you need to multiply the number of decays you got by 2, and then you get how many decays have occurred in total, and then you know how much is in there. Extremely nice. Why don't we do this with everything? Because annoyingly, the half-life, which is usually expressed as T1 half, T1 half. Annoyingly, the half-life of most elements or of a lot of isobars is a lot longer than a year. So half-life means that after this time, half of the nuclei that were in there that could decay have decayed on average. This is a statistical thing, but there are so many particles that essentially this is true. Okay, and now comes the annoying part. Hang on, there we go. Now comes the truly annoying part. Let's say you have a graph here. By the way, Professor Phil Bell in the chat, thank you for sticking around, by the way, has said that americium-241 and cesium-137, very nice, in solids has been used to determine the ratio of natural isotopes to those delivered by the bombs in Hiroshima and Nagasaki. Exactly, these are some of the ones that can be used. And there have, due to the atomic bomb tests in the 1950s in the atmosphere, actually we had a bomb peak where you can really see an increase in, for example, carbon-14 in the air. And as horrible as nuclear weapons are, in my opinion, they were extremely useful for this kind of dating, because now we have a fixed point. There has only ever been one point in history that we know of where the carbon-14 concentration in the air has been that high. So if it was that high, you can say with great confidence, this thing is that old, exactly that old, as a matter of fact, which is very interesting. Regardless, let's go back to our topic. Let's say here we have on the y-axis, we have the number of of nuclei that we want to look at, right? So the nuclei, this one's not in total, not of the whole lump, but just the specific one isotope that we're looking at. And down here we have time. Now, most of you have probably learned in school that this works with that the number. We're gonna write it. I'm gonna write it down here. I think that the number at the given time is how is can be calculated with n0, so how much you had in the first place, times e to the minus lambda t, where lambda is a decay constant. I think it's called. At least, yeah, I think it's called the decay constant, or the decay rate or something like that, which is specific for each element. You can measure it. It relates to the half-life. Neither here nor there. Now comes the important part. So this part here means that we have an exponential decay. So without giving it any numbers, it would look somewhat like that. Right? Maybe I'm drawing it rather ugly here. I'm sorry. I'm a scientist, not an artist. Okay. Or I want to become a scientist, not an artist. And now comes the annoying thing. So far, everything would be fine. If it was just like that, everything would be great. We could count everything. You take out some amount of material. You somehow figure out how much material is in there, and you can date it precisely because this function, this exponential decay, has only ever one given x value at one given y value. So at any given time, it only has a single number of nuclei. So you could never have two. Unfortunately, life isn't all easy and dreams like that. Very annoyingly, you must add something to that. And this is the background noise. Because you're using whatever you're using to determine that will not measure anything perfectly. And so you have a background noise that may look something like that. So at any given time, even though you're not measuring anything that is radioactive, you will pick up a few counts, as we call them, in the detector of something radioactive. Those may come from the uranium that's in the ground. Those may come from radon gas that's in the air. Those may come from cosmic radiation if you're high up a mountain. Which, by the way, an Austrian physicist that goes to the that was from the university that I go to has gotten the Nobel Prize for discovering that. Victor Franz Hess, who found the cosmic radiation, not the cosmic or the microwave background radiation, not this kind of radiation, but the cosmic radiation that comes from space down to Earth, and this consists of highly charged particles, highly ionizing particles. I mean, Ella in the chat says you're a scientist already, as opposed to becoming it. As I have heard from reliable sources, I am, as I've mentioned a couple of times previously on this channel. I am in the process of writing a paper, but this is so difficult when you have two professors that have so much other stuff to do, and when you're writing another master's thesis on the side, you really have to do. But technically, I have a master's in astronomy, and if that qualifies me as a scientist, then I'm a scientist. Yes, that is correct. Thank you very much for reminding me. Okay, so back to the topic at hand. If you do that, if you have this is from the background. I should write it down. Background. And this is our decay. So annoyingly, and I'm now doing it in orange, the overlap of that will look something like that. And suddenly down here, you start doing that. And now, from this point here, roughly onwards, you cannot date it anymore. Not dateable anymore. That's annoying. This is like me. I'm not dateable anymore. I'm sorry. I have to make these kind of jokes when we're talking about dating. Okay. And this is where this is the crux of the thing, because this is roughly now, of course, this depends highly on background levels. But for example, for carbon dating, we say that this is 6 times the half-life, roughly. Carbon-14 has a half-life of 5,000 somehow many years. And so after 6 times that, so roughly at 30,000 years, this method stops working. this completely stops working. Thank you, Ella, for disagreeing. This just stops working. It's not reliable anymore. You're just going to measure the background, and you can't really make extrapolations if you have the background. And now what Will Duffy has just said here, and this is a point I would like to drive home here, right? So Will Duffy has said, well, Duffy, I'm always unsure how to pronounce it, because I thought it was Will Duffy with an A, right? But conspiracy cats or cats always pronounces it as Duffy. And so I'm not sure anymore if this is whether that just is his British accent or if I'm pronouncing it wrong. All right. So Will Duffy has just said that they took something. Let's have a listen to it again. Hang on. There we go. He has just said,
is a young Earth creationist, PhD geologist who's a fellow Aussie. Okay, his name is Andrew Snelling, and he dated.
Yes, I mentioned him previously.
Yeah, there's something that was discovered in Australia. It was some sort of petrified wood, and it was both carbon-14 dated and potassium-argon dated.
Okay, so carbon-14 dating works like I've shown you, and potassium-argon dating also kind of works like that, but you don't measure a single thing, you measure two things. I mean, with carbon-14, you also don't measure a single thing. You measure the 14 carbon if you want to have the best results in relation to stable carbon. And with potassium-argon dating, you're looking at the decay chain from potassium-40, which is radioactive, and you measure how much argon is in there and how much potassium-14 is still in there. And from that, you can calculate, with the assumption that argon hasn't somehow found its way into there in large amounts, that you then can calculate the point on this curve that you're at, and you can thus determine the time, right? So, but now what gets me is he said there were carbon-14 dated, and they were potassium. No, that's potassium is K. They were potassium argon dated. I am bothered by that statement. If we look it up, I did it just about earlier. Potassium argon dating, depending on best would be, according to Wikipedia, best would be over 100,000 years. Oh wait, sorry, 100,000 years. And from what I can find, for example, from Encyclopedia Britannica, they say from 20,000 years, but this seems to me to be on the exception here. So 20,000 years to roughly, let's say, check. Oh, I'm still streaming the wrong screen. I'm horribly sorry for that. I need to do this one. All right. And potassium argon, according to Encyclopedia Britannica, goes from as young as 20,000 to, dear God, 4.5 billion. So that's times 10 to the 12. Times 10 to the 9. I'm sorry, 12. Jeez. Okay. This is the age range of potassium argon. Now, if we look at the age range of carbon dating, because methods for carbon dating have been refined over the last couple of centuries, I said something like 6 half-times. Here we are closer to 10 half-lives. So wait, I need to make a rep here. And this is less than 60,000 years. But I, from what I know, you need to be pretty lucky to get it with that, honestly. I mean, again, there have been facilities recently that can do it to a high degree. Ours can do it, or the one that I'm currently at can do it to a very, very high degree, competitive in the international range. I'm just having a look if they list an example on Wikipedia. Is that our facility? No. I was just thinking quickly that they had a picture here of our old facility on the Wikipedia page, but fortunately they do not. That would have been quite outrageous if I didn't know that. Yeah, radiocarbon dating is generally limited to dating samples no more than 50,000 years old. However, blah, 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 these techniques can allow measurements of dates up to 60,000 years, and in some rare cases 75,000 years. So let's say 50,000. We you know what? Let's let the 60,000 here be. Okay? So, and Will Duffy now says that they have been used carbon data, they have been carbon and potassium argon dated, and they've gotten severely different results. Oh, really? What else is new? Like, you cannot interchange randomly different dating methods. You cannot do that. You will get a significantly wrong example. So if this is his evidence, and if this comes from a geologist, then the geologist isn't worth his money. I'm sorry. This is important here, okay? Of course, these two are very much likely not going to agree unless you are on the extreme ends of both of these methods. How should they agree? If you sufficiently understand what is going on here, they cannot agree. Okay? and I find that very annoying to bring this up in a discussion, but from what I remember, it gets worse.
And the difference in the dates was wildly different.
Of course it was. There is no other way in it being so.
That's one example. A second example is things are dated like lava that we know when it was formed, or rock that was formed in Mount St. Helens explosion, and the dates are wrong, but we actually saw those form.
Particularly,
so again,
again, I'm not a geophysicist, I'm not a geologist. I know somewhat little about the rock formation in volcanic activity, but I think one of the base assumptions in dating stuff is that there was not some cataclysmic event. For example, a volcano eruption, because you might have in the lava, you might have some lumps of stuff that have, for example, a different composition than the liquid part around them. And if you then try dating things, well, obviously you're going to be wrong. For dating, ideally, you have slope processes.
I just think it's a little bit, I think we should be careful to think we can't be wrong about dates millions and billions of years ago when we're wrong about things that are less than 50 years old.
Okay, so to answer those questions, the laboratory that sample was sent to, on their website, it says that you cannot use potassium argon for samples that are that new. So again, this is like trying to detect a tooth cavity with an aircraft radar.
Yes, that is precisely,
and the error
that is
on
precisely what's going on here. Will Duffy is essentially accusing science of not being able to measure to measure, for example, the temperature in this room with an electric toothbrush. Yeah, of course we can't. How do you imagine we do that? That's the wrong tool for this specific job. However, now that it might have been a poor example because an electric toothbrush is not a scientific measurement instrument. Regardless.
The error returned by that was 320,000 years, or 3.2 million. I can't remember exactly, but it was
a high error, obviously, because this is what you're going to get there.
If you start using the same date, you get billions of years. Being an error by 3.2 million is irrelevant. If the technique is only accurate to within 3.2 billion, that doesn't allow you 3.2 million. Sorry, that doesn't allow you to suggest that the technique is worthless on those larger length scales. Similarly, when we use radiometric dating on the Pompeii eruption, the Mount Vesuvius eruption, we get exactly the right date. We get exactly the date that corresponds with the historical evidence we have. About that, yes. So that claim is false. We can get into the shortcomings of radiocarbon dating, and why young Earth creationists are very keen to present radiocarbon results. Radiocarbon, if you get a radiocarbon age from a very old sample, a fossilized sample, that means nothing.
For the exact reasons that I have explained, I would like to remind everyone here and for the future of people watching this live stream, which are going to be thousands and thousands of people. I just know it. This is because of that, right? I said 6 here. If we take let's say 10 for carbon here, right? This is because of this very thing that I drew here, right? So you have, I hope you can see my cursor. I think you can. Yeah. So this is because of that here. As the thing decays, less and less of it will be here. And at some point, it will approach the background. And if it has approached the background, you cannot give a reliable answer anymore. Of course, you can still calculate an answer. You can still say, well, this much activity, or this many radioactive atoms or something like that, depending on how your counting methods there works, or if you detect radiation, or if you count atoms with an accelerator, or things like that. Depending on how this exactly works, you can still calculate it where you would expect this value, but because this is maybe not different from the background. So say you pick up 30 counts in an hour, but your background is 28, well, that's it. Only from counting statistics alone, this measurement is not reliable anymore. Professor Phil Bell, I have to go now, but I'm looking forward to watching the rest of your stream. Thanks for your effort. You are so kind, Professor Phil Bell. Thank you so much for dropping by. Made me somewhat happy. Thank you very much. Have a great whatever time it is where you are. All right. And that's the crux of the matter. You cannot carbon date something that is ancient. I mean, you can carbon date ancient things in a human definition of ancient, but you cannot carbon date a canyon or the stones therein. That just won't work. You will get completely nonsensical results, right?
It could mean that the sample has been corrupted by
not to speak of contamination with good samples, because that happens a lot and is very annoying.
I've got a presentation on that. Do you want to see the reservations that you should have when somebody presents an old radiocarbon dating?
Well, I just heard something you said that sounded like begging the question to me.
And you're up very early then, Professor Phil Bell, and have a very, very nice morning and a very, very nice day for that matter.
You said that dating method doesn't work on something. What was the exact phrase you used?
This is how AI optimizes my...
I'm sorry. Go away.
So radiocarbon dating doesn't work on very old material.
Okay, perfect. So let's talk about that, because I have an issue with that statement. Okay.
But it is very correct.
And it gets back to my example with Jack Horner. If you're going to assume your conclusion, that's what the begging the question fallacy is. If you're going to assume your conclusion that it's old, and therefore say that this dating method won't work on that specimen, that's not science to me.
Because this is due to the fact that you don't know how carbon dating is actually done, which is fine, right? I don't expect anyone who doesn't work in the field to know this. Heck, most physicists even don't know that. What you actually do when you do carbon dating, and now we were going to get technical again. Lovely. I'm going to... How much time do I have left? Okay, I have about little less than an hour. I want to stop at 10 because I will have a very, very stressful day tomorrow and on Tuesday. Okay, so what we use is mass spectrometry. You may have heard of mass spectrometry. This is one way of measuring things like that. And it works when you have some source and you make your atoms or your ions or whatever you have shoot out of it. And then you have a magnet. Going to draw it rectangularly, but it's usually not. You have a magnet, I will say, with a B and an arrow. That's a B field. That's how we express magnetic fields in physics, for one example. And the ions move through here, right? If they're charged, let's say for the sake of our example here that they're negatively charged, right? so their charge is negative. You might have heard of the Lorentz force, the magnetic deflection kind of. If charged particles move through a magnetic field, they get deflected, and you can think about it with the so-called right-hand rule, right? So this is your movement direction. In this case, it is upwards. Let's say upwards. The magnetic field applied, let's do, for our example, into my monitor here, so directly at you. It will be like that. And the middle finger now tells us how it's going to be deflected. So in this example, if we're moving upwards and the magnetic field is applied in this direction, the particle will deflect to the left. Whee! So it will do kind of an arc here, right? So the magnetic field goes into my screen. You signify this, by the way, in physics. This one goes into the screen, and this one comes out of the screen because we think it's an arrow. So this one is in, and this one is out. And so this gets deflected to the left. But how does it get deflected to the left? What's its deflection radius? Well, you can look this up now, but in general, the radius, right? The radius will be a stronger magnetic field will mean that it gets deflected more, so it will decrease the radius. If it is faster, it will increase the radius. I'm spitting all around because I'm overpronouncing some of the words now. Because sometimes in English I have a little bit of an unclear pronunciation, and I want everyone to understand what's happening right here. So this is why I'm speaking a little bit more like that. So the velocity is here because if it's faster, it has less time to interact with the magnetic field, and it's going to be deflected less. Right? Then, if it's more massive, it's going to be deflected less, so the radius will be bigger. Right? And now these are in some relationship. Of course they are, right? And depending on what exactly you're putting through there, and how your measurement is constructed, if you want, you can achieve different results. And that's the kind of thing. And of course, if your particle is charged more. And this is actually the equation, by the way. I just looked it up just to be sure. I don't want to mess anything up in a kind of educational video. So I briefly looked it up. So this is the equation that we're talking about here. I'm going to. This is for a magnetic field, obviously, because we are in a magnet here. So depending on your mass, your charge, and your velocity, this is going to look differently. The radius will be different. So if you have two very different atoms, one of them is going to end up here, and the other one is going to end up down here. And now you can count how many you get with a particle detector. This is the basic principle of what a mass spectrometer does, and you can use this, for example, to measure different masses. You can be even more tricky. You can not only do this with a magnet, but you can also do this with an electrostatic field. Not only with a magnetic field, but also with an electrostatic field. Because as it turns out, with an electrostatic field, you can sort according to different things. Here, you sort, the R is proportional to, this is what this alpha means. That means proportional to the momentum, because m times v is the momentum, over the charge at a fixed magnetic field, of course. And so this is for a magnet. Yep. Oh God, I'm writing. Sorry. Magnet. And in an electrostatic field, R is proportional to the total energy, so the kinematic energy over the charge. That's in an E field. And this is very cool. Imagine now, for me, if you were to put one of the magnets, which are from now on blue, and one of the electrostats, which are from now on green, behind one another. Let's say we have a magnet here. Wait, let's actually try and draw it. Yeah, I've done worse. Which is the magnet. Oh, I'm so sorry. That's the magnet. And then you're going to put an electric field right after that. Oh, wait, I'm sorry, I should draw it like that as well. So there we go. Oh, that one is nice. That one's really nice. And now you have sorted whatever comes out of here, not only according to its momentum over charge, but also according to its energy over charge. And with that, you can now determine very, very well what the thing is that comes here. In case of carbon dating, I'm going into a little bit more detail now. In case of carbon dating, out of this ion source, right, which all work differently, we at our thing, we use a cesium sputter source, which is just a complicated mess, frankly. So out of the ion source, right? It's usually drawn like a rectangle with an opening, which isn't too far from reality. It's like usually drawn like that. This is the source. And out of our source, in terms of when we do carbon dating, out of the sample, we have a lot of carbon-12. We have a little bit of carbon-13, because this is also stable. It's just a lot less common in nature. We hopefully have carbon-14, but we also have things, we also have carbon-14, but we also have things like 12C with an H. We have 13C with an H. We have 14C with an H. We have all of these with 2 H's, so blah, 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 with H2, each of them. We have some, all of these are negatively charged, by the way, usually singularly negatively charged. You can have iron that can come out of there. Let's now, for now, stick with carbon. Now, if we want to measure carbon-14, something that would immediately annoy us would be nitrogen, which is one of the main composites of the air, because it has a stable isotope at mass 14. This would be a problem. Luckily, nitrogen doesn't form negative ions. So this problem is solved by a smart choice of which ion you're going to look at. And now, what you can do is you can filter for mass with the B and or you can filter with the B and the E field, and then you're only left with things that are mass 14. Let's say then we have 14C, but we still have 13C with 1H, and we have 12C with 2H. Those are also still there. And in carbon dating, these are a problem. They are all mass 14, but after this first step, these are the ones that are left. And now here comes the genius part. Imagine that we're using, can I select it actually? Can I select the part? Yeah. Oh, no, this is not what I wanted to do, but nice knowing that this exists. Shapes. Shape style. Oh, well, no, that certainly didn't work. Can I? Selector. Yes, this is what we wanted. I can copy it. Yes, very nicely. Okay, now go back to a problem. I'm sorry if this is too technical. There are only 2 people left watching, and I understand why. Now let's say we put here, we put an accelerator in yellow. This is a rather visible yellow, so I'm using it. This is an accelerator with a few megavolts, right? The big ones have like 14 or 13, and the small ones have a half. So, but the principle remains the same. Ours is 3, if you want to know. Let's say a few million volts. And what the accelerator does, and this is very nice, it has stripping gas inside. And the stripping gas, because the things that come out of our first part here, they are being accelerated with so much energy suddenly and they hit the stripping gas, that molecules get destroyed. And this is so cool. So, no more molecules. Molecules. So, we can now throw out the 13C with 1H and the 12C with 2 H's in the negative charge state, of course. These don't exist anymore. We have eliminated them. So everything that comes out of here not only has only mass 14, but is not a molecule anymore. So only nuclei now have that. Now the charge state usually changes. This was the negative side here, and this is now the positive side. Not singularly positive. We're usually talking about 2 positive or 3 positive, and big labs go up to 13 positive or some crazy thing like that. And now you can do another really smart thing. Now that you have only all of the nuclei left that came in here that originally had mass 14, technically you could still have a nuclei now back here that in as a molecule had mass 14. Now you just do the same thing again. You put a magnet back here. And you put an electrostat right here. And you have just solved all of the problems. Because you can select for mass again. This here is the detector. You have solved all of the problems that you had with the original approach. And this is what the facility does where I currently do my master's thesis at. We have a big accelerator, and I like it. It's really cool. The facility is cool. Some of the work that you need to do for the facility is not so cool, but that's neither here nor there. All right. And now, if you remember earlier what I said, now you can measure. Now we can count, and it's literally counting 14C, because our detector can pick up to, I think it's reliably 20,000 counts a minute, or was it a second? No, it was a second. So, something in that regard. So everything that's below that, we literally count it. We say, there's one, there's one, there's one, there's one. And then we know how much carbon 14 we had. Now, because only knowing how much carbon 14 we had doesn't really help us if we don't know how much carbon there is in total. Usually here, you have some station that can count the stable carbon, right? Usually not counting anymore, but it does it via counting the total amount of charge over a given time that was deposited. And then you can make a ratio. Yeah. Can, let's say, measure stable carbon, and now that's the important part. An age determination is now possible. And this is how it is done at the best facilities in the world. So when Will Duffy says that oh, this and that is a problem here, well, that's because he kind of doesn't know how this works, right? And again, it's not to blame him. I'm not saying, oh, I'm just saying that he clearly doesn't know. And so his opinion there, unfortunately, is misinformed.
It gets back to my example with Jack Horner. If you're going to assume your conclusion, that's what the begging the question fallacy is. If you're going to assume your conclusion that it's old, and therefore say that this dating method won't work on.
But we're not saying it's old and thus it doesn't work. We can see that it doesn't work. Because if in the detector, right, if we measure, or we count rather, if we count, let's say, 10, 14 carbons over an hour, and our blank, this is called a blank, which is a known thing that has no carbon 14 in it, no 14C, also gives us, like, let's say, 8 14 carbons over the same hour. Well, we have a problem, Houston. That's bad. Because our counting statistics, if you want to get fancy now, our counting statistics says that this 10 comes with, maybe I should, so that's really 10 plus minus the uncertainty, and the uncertainty of counting statistics comes out of the uncertainty of a Poisson distribution, which is the square root of 10. That's 3 point something. So really, and 8, it would be 8 plus minus the square root of 8, which is 2 point something, right? So unfortunately, we can only say that we get as many counts. These agree with each other, by the way, for people like Flatsoid who don't know that. This means that they're in agreement. This means then that we cannot make any determination about its age anymore, because we know that that one does not have any carbon-14 in it, and they give us the same, within uncertainty, the same amount of counts. That means that the result that you have is unreliable. We can only say the only determination that is possible from a physicist's point of view is that whatever this is, it is too old for this method to work. We can only say that whatever this is does not give us any more counts than something we know has no carbon-14 it does. That's it. So when, oh crap, I streaming the wrong screen again. I'm so sorry. I need to stream that, right? So these two agree with each other. And so we can only say that no age determination is possible. We can only say somewhat reliably that it's likely above 50,000 years, let's say, or 60,000 or something like that. With a little question mark. There's always the chance that something got wrong in the chemical sample preparation, or that the material wasn't the material that they wanted to do, but if we say that everything of that went great, then yeah, that's a problem, right? Exactly. So, and that's why why I was really bothered and why I wanted to talk about it. And I'm sorry that it took me over an hour to get here.
That specimen, that's not science to me.
That's because, unfortunately, you didn't really understand how it's done. And that's not supposed to be an insult. I hope if you would watch this, first of all, hi, thank you for watching my videos. But if that's the if you see this, that's not supposed to be an insult or anything. I'm not insulting people as a rule of thumb.
Okay, but you need to understand that if you get a young radiocarbon age from a sample, that doesn't mean that it's young.
That's correct.
Because because radiocarbon has limitations.
Very well known limitations.
So, and I can only answer this question by discussing radiocarbon dating.
Yes.
I've got a presentation on that. Would you like to? Because these are things that are often misunderstood by lay people, and I'd prefer to.
Yeah, I just want to point out for people in the chat, because the people in the chat are now acting like flat earthers. They have no idea what I'm talking about in terms of original biological material found inside of dinosaur bones. And you're talking about it like you do. You probably don't even care.
This is one of the most famous examples, by the way. The woman that did that was really, really sorry that creationists used their things as evidence, because she specified it 100,000 times that this is not what that means. Simulacrum, you're still here. How nice. This is why I don't always like debates, because you cannot educate someone in a format where they are supposed to take the opposite position. That is correct. I'm not. I think debates are a great way of getting two different opinions established quickly, right? And therefore they're great. But I think debates should have a more strong limitation to opinion-based things more than things where obviously someone doesn't know their arguments very well or the physics behind their arguments. And if I was sitting there, first of all, I mean, PhD Tony comes from a geophysicist or / geology background. I come from to be quite frank, mostly astronomy and somewhat physics, but not mostly nuclear physics or isotope physics background, and maybe a tiny, really small little bit of everything else. So of course we would use different arguments, but I would have tried to explain that to Will Duffy, and I think in this case he would have been quite receiving to this kind of information, because this is my judgment of him, let's say.
Actual research, which is in all of the mainstream science journals. And someone even made a comment that you don't carbon-14 date something that's that old. And again,
Exactly.
that is not science.
It is,
Fortunately,
because it is the correct
even though the
tool. I'm
science
sorry.
community hung Mary Schweitzer for saying it was
Mary Schweitzer
original
was amazing.
biological
Yeah.
material, they tried to tell her it was biofilm. Fortunately, people were able to do real actual science, and there's now been
here Will shows, in my opinion, a characteristic that is done with flat earthers. He has now become the arbiter of what is considered real science. That's usually what flat earthers do, right?
not only carbon-14 but DNA inside of these dinosaur bones.
That is correct, but it has since been found out that iron actually has some kind of preservative properties for DNA and things like that. This is one of the most common young Earth versus usually atheist debates on YouTube. I'm not the one to explain this to you. Some other should do. The age of the Earth is flat, says Simulacrum. Yes, I think I mean, we would need to talk about what it means for an age to be flat, but I like the way this is phrased. The age of the Earth is flat. Yeah. Yeah, no, I know that this is a joke, but I like how it's phrased. Yeah, I will go on and say that from now on. That's funny.
So this is very significant to the age of the Earth.
Okay.
Naturally.
Okay. Does Mary Schweitzer agree that the Earth is 6,000 years old? Because you keep
She
on citing
doesn't,
her
by the way.
work, and she doesn't agree with the conclusions that you're coming.
That's
But
correct.
let's move on to the technique of carbon dating.
Great.
So carbon dating was invented in the 1940s.
Got the Nobel
Carbon
Prize,
14 is
by the way.
created by cosmogenic spallation.
Yes, which is really
You
cool.
get high energy particles.
And an Austrian
into the
dude got the Nobel Prize for that. Haha.
atmosphere, they hit nitrogen. That's an illustration of carbon-14. The spallation occurs with the oxygen and the nitrogen in the atmosphere.
Yes.
This is radiocarbon decay. There are two styles of radiocarbon detector.
Yes.
The first one basically detected the beta particle emissions,
You can do
electron
that,
emissions.
but the issue is that the half-life, you need quite a substantial amount of carbon to do that.
The second
But sure.
Our
Okay.
Muslim brothers and sisters in Yemen.
Okay. So in the meantime, PhD Tony has, by the way, commented to my comment. Wait. Oh, sorry.
acceleration.
Yes, that's what we do. That's essentially what I explained. This is precisely what we do at the facility that I do my master's thesis at almost every week.
So this
I'm
is
just not one of the people that does it.
mass
I
spectrometry.
did it once.
You chop up the sample, you filter it, you ionize it, and then you send it through an electrical field.
Yes,
The amount
very
of
briefly. But yes, you can do that.
carbon-14 in the system is, as I said, a function of the strength of the electromagnetic field, which varies with
Yes.
the electromagnetic field. Here's an illustration of sort of variations in cosmogenic nuclides in particular.
Yes, I have a whole
1400, and
presentation.
This is
myself
more
about
illustration of
cosmogenic
that.
nuclides.
Okay, so what are the problems with this data set? One is sample preparation, because the samples,
Yes.
we get carbon, it gets taken up by plants, the plants get eaten by herbivores, the herbivores get eaten by carnivores, everybody dies, and their remains end up in the soil.
And as soon as organisms die, the exchange between the carbon in them and the carbon in the air stops, and you get when you carbon date something that was living, you get the date at which it died.
The sample can end up encrusted with young material. Yes. It can be permineralized, which means sort of
in general contaminated.
Mineral
I don't know it as precisely as Tony does here. Obviously, I just know that 14 carbon can seep into the thing that you'd like to measure, and this is true for most of the dating techniques that are done.
Intrusions into your sample. It can also have microbial action contaminating your sample. You can also have what's called remineralization, where phosphate ions inside your mineral are replaced by young carbonate. So the presence of young carbon in your sample.
About that.
The other thing that can happen is nearby radiation sources.
Yes.
So if you've had a
that's the background
radiation source that produces neutrons near your sample, it will emit neutrons. They will hit the oxygens and they will produce carbon-14,
which is one possible
presence
source
of so the presence of radiocarbon of young carbon-14 in this material is no evidence whatsoever that the sample was actually young. You have to eliminate the various other forms of error that could have happened.
That's correct.
The other limitation on radiocarbon dating is what's called the ocean reservoir correction.
I don't know much about
atmospheric CO2 dissolves into the ocean. It's eaten by microbes. They get eaten by
and so on
because it hasn't been eaten by an animal yet. So you need to apply an ocean reservoir correction to depending on how far away from.
I'm just waiting for one more specific thing that Will Duffy said, and then I'm happy.
You are. So there are limitations on radiocarbon dating, and the fact that a radiocarbon result
but I think
yields a young.
Oh, everything that Tony has said here was nice. The fact that he did not mention the thing with the background that gives it its upper limit. That's sad, because I think that would have been the crucial point here, in my opinion.
Age is in no way logically requires that the material that the sample was young. There are multiple pathways for young carbon to get into an old geological sample. So this old staple of and again, like, the thing is, it's not like experts in the field have not heard these arguments. We have heard these arguments. We know why they're wrong. And it is a little frustrating that
very frustrating.
The scientists who base their careers around this and around the accuracy of geochronological techniques are being told by people who don't understand these techniques how they should do science. There's a reason we don't use radiocarbon-14, and we don't accept that young radiocarbon in diamonds or coal or whatever else you're looking at means that they're young, because it doesn't. It means that your sample's contaminated,
or that
maybe you should find a better sample.
Okay, so this is important, Tony. This is super important. I think, and you can correct me if I'm wrong, but I think I'm the more objective one here on this topic. I think that it's possible that you're right about this, but I think it's also possible that it's not contamination and that it's original biological material, and that we should look into this. We should do more testing. We should look for more specimens out in the world. You sound like you are closed-minded. It has to be old. I know I'm right. Therefore, it must be contamination.
I don't think
Ich habe mein Traumwohnzimmer mit.
I don't think that is closed-mindedness. It's just it won't change anything to remeasure it. It's like a flat earther saying, "Oh no, we should make more experiments about the shape of the Earth." Why? That would be a waste of resources, because we know. Oh, sorry.
Okay.
Be contamination. Game over.
Okay, so at the moment you're sounding very much like a flat earther. This is exactly the sort of argumentation that a flat earther takes. And the difference is the abundance of evidence. So far, I brought up one dating technique. There are several other dating techniques. There's also an abundance of evidence. How do you explain the fact that there's a 2 kilometer thick layer of glacial till in Oman?
I need to respond to something you said. All I said is that you might be right or you might be wrong, and you say that I sound like a flat earther.
Yes, which is exactly what flat earthers say. Yes,
So
that's exactly what flat earthers say. Flat earthers say that it's possible.
Forget if flat earthers say that. What is wrong with my statement that I think you might be right, Tony? I'm telling you right now, but I also think it's possible you're wrong.
Yeah.
What is wrong with that statement?
Because the confidence I have in my conclusion is proportional to the abundance of evidence supporting that conclusion.
Yes.
We have not
I think
covered even a tiny scintilla of the available.
I could swear that at some point Will Duffy said something that I would like to then again talk about that I think shows his inaptitude about these things. I'm almost thinking I imagined that.
Evidence
I will give it 10 more minutes, and if we don't cover it by then, I will have to surrender and say that I imagined that.
conclusion. You are not aware.
By the way, the next stream that I will do either next Sunday or the Sunday after that, I think so, is about a 1-hour video of a flat earther about gravity, and I have only watched the first 5 minutes, and they are great.
Of the vast majority of evidence supporting my conclusion.
I don't even know what your
well,
conclusion
could
is. You haven't said what your conclusion is.
So my conclusion is that the preponderance of geochronological evidence directly contradicts a 10,000-year-old Earth and establishes Earth's age as 3.56 billion years, plus or minus a few million years.
I think it's some other number.
That's what the evidence suggests.
I think.
Okay, I am shocked right now, and I'm a little bit perplexed. Yeah. I've been told by mainstream science that the Earth is
4.56.
4.5 billion.
Yeah, sorry. Yeah,
okay.
That's right. 4.56. Sorry.
There you go.
Okay, good. That makes me feel a little bit better.
I've been reading papers about stromatolites that are 3.52 million years old. So that was the number that was in my mind. But yes, 4.56 billion. You're quite right.
Okay. So someone told me recently, and I immediately knew they were wrong.
So
they told me that multiple
a message. Okay. I mean, cool, right? But why though? Okay. Fine.
Fields of science.
I didn't know that was
all
possible,
independently date the Earth, and they all come up with the same answer. That is false.
Yeah, that's not false.
No, if they use the
that is false.
Rules,
so Tony, here's what I'd like from you: is I want you to tell me right now, other than meteorites that did not originate from the Earth, what shows us the Earth is 4.5 billion years old?
Okay. Material on Earth has been dated to that far back.
No, that's false, Tony. I'm sorry. I have to stop you. Nothing from the Earth has been dated at 4.5 billion years old. Nothing.
Yes, because it has to. Now you are actually using science denial as tactic.
And this is where Tony gets irate very quickly, and I kind of don't like it. But I mean, he's correct.
And I am extremely resentful of it. So do you accept then that material has been dated to 4.1 billion years old?
I'm not okay. So you feel it?
Don't do this.
No.
Like literally. So you're saying that the scientific material that has been dated to 4.1 billion years old isn't consistent with a 4.56 billion year old Earth.
So for example, if Will Duffy's argument here is that dating is inconsistent, then why do we get very similar ages for? I'm downloading the picture. Oh, that's just great. I'm sorry. What? No, you. Sorry. Go away, please. No, I don't want to log in. Oh my god. Thank you very much. Strange website. There we are. This is the carbon dating result of Ötzi, which is an extremely famous iceman that was found in a glacier in 1991. He was found like that, and you can carbon date this man and his stuff, right? And when you do so, you find that they are extremely consistent, only disagreeing with his surrounding plants, some of the surrounding pieces of wood that were found, and with the grass surrounding him. But all of his stuff, his charcoal, and his the stuff from the bars, the moss, the grass around him show very, very consistent ages. If carbon dating was ridiculous, why do we get very consistent results in this case? And you can also see the animals that came by, which I really find interesting. Yeah, this was, by the way, done by what I have heard a very, very amazing facility for carbon dating. But that's neither here nor there. Simulacrum in the chat says, I was just saying that someone should find an equivalent of the 24-hour sun in Antarctica, but for the age of the Earth, something that Will Duffy will have to witness for himself. That's difficult, because the flat Earth, they're disputing things that are happening right now, which is there is a 24-hour sun in Antarctica. And the problem is when Will Duffy says that Earth didn't form out of a protoplanetary disk 4.5 billion years ago, well, I can hardly take him back. I could show him all of the evidence that we have for that. But yeah, that's neither here nor there. So I'm giving it 5 more minutes and then I'm stopping if I don't find what I meant. I hope so. Yeah. They are different by about 10%, which, given that high age with a dating method, is very good. No, they are different by about 10%. That's correct, because they cannot be evidence. And this is where I'm getting annoyed at Tony, because he gets so offended by that so quickly, and I think that's sad. He shouldn't be. Oh yes, you cannot see the video. I'm so stupid. Thank you, Simulacrum. Sorry, Tony gets.
So you're saying that the
unfortunately
scientific material that has been dated to 4.1 billion years old isn't consistent with a 4.56 billion year old Earth. This is just mendacity, Will. And if a flat earther were doing this, you'd rip into them.
Yes, that's correct.
4.1 billion and 4.5 billion are insanely different numbers.
They are different by about 10%. So no, they're not different.
They like to poke holes in the globe, but they don't like to show evidence of their position. I asked you for your conclusion because dendrochronology and ice cores are not evidence that the Earth is 4.5 billion years old.
That's because they cannot.
So I wanted to establish that you.
Hey, Will, shut up right there. Shut up right there. So again,
I don't like it when Tony gets so irritated by small things.
I said that the confidence in my conclusion is based on the entirety of the evidence available to me. It is not based on dendrochronology. It is not based on ice cores. But with dendrochronology and ice cores, I can refute your position that it's 10,000 years old. You are making a claim that it's 10,000 years old, which is instantly falsified by ice core data.
Maybe Will Duffy will pull a good old flat earther tactic here himself and say, no, I'm not claiming an age.
It's instantly falsified by sea level data. It's instantly falsified by all chronological data. And to claim to start picking holes, this is exactly what flat earthers do. Flat earthers, I was going to ask you about how you explain 2 kilometer thick strata in Oman. So we have glaciological strata 2 kilometers thick in Oman. How did that get there?
Okay, I'm sorry, Tony.
When did that get there?
Sorry, Tony. I will answer you, but I can't let this go. So you said, anybody can hear this, that multiple fields of science date the Earth to the same age. That is false. The 4.5.
No, that's not false.
Okay, where does 4.5 billion years come from? That exact number, where does that come from?
It comes from the position of Earth. the position, well, there are multiple data sets. The position of the sun on the main sequence of the Hertzsprung-Russell diagram dates the sun's age since its formation. We can look at the
sorry, Tony, we're talking about the age of the Earth. Sorry, the sun is not the age of the Earth.
But the sun and the Earth.
No, but the age of the
in the thing of during the process of planet formation.
This is like saying that the sky has nothing to do with the floor, Will. That's exactly the same argument. And the fact that you are unwilling to admit it is a sign of your intellectual dishonesty, to be brutally frank. The age of the sun and the age of the formation of the solar system is very much a constraint on the age of the Earth, and maintaining otherwise is simply dishonest.
Extremely so. That's completely true.
We can look, for instance, at the we can determine how the Earth was formed. We can determine from the evidence available to us. And again, this is very much like saying, show me a picture of the Earth with planes flying upside down. Obviously, no zircons survive from that early in the Hadean, but that doesn't mean that we can preclude a 10,000-year-old age. That the fact that you will freely admit that we have geochronological data from 4.1 billion years ago, and then go on with a straight face to suggest that it's possible the Earth is 10,000 years old, is simply meretricious.
I never agreed to 4.1 billion.
Guys, I'm sorry for jumping in. Oh shit, I'm muted. Oh no, sorry, I'm not muted. I'm just swearing for no reason. Sorry guys. I'm just wondering, the last thing I want to do is like interrupt the conversation. I'm just going to offer this, and if you don't want it, I'll step back and shut up. I feel like you've both got things you want to say. Would now be a good time where maybe we just say, listen, Tony, I'm going to give you 5 minutes to say everything you want to say.
Yeah.
And
Unfortunately, I'm running out of time here, and I think I must have imagined the part. I was sure that Will Duffy at some point said something was tested positively for carbon-14, and that meant something, in which obviously that's a meaningless sentence. That we know what we know. So briefly recap. This is now close to the end of the stream, by the way. So you can start leaving if you want. I'm just going to recap what we did. When you talk about dating methods, generally you can't get much higher than 10 times the half time. And most of the time, not even that. Because at some point, you're going to hit some background radiation, or you're going to be within the counting uncertainty of the detector that you have within 0. At some point, this is going to happen, right? Just based purely on the physics that we know about these things. And Will Duffy has brought forth an argument brought to him by some other person who said that, well, they carbon dated some petrified wood, and they potassium argon dated the same piece of wood, and they came to completely different conclusions, which is the only thing that makes sense. They should come to completely different conclusions, because these two dating methods have severely different dating ranges. Then I've explained to you how we select for these masses with accelerator mass spectrometry, because we use an accelerator and we do mass spectrometry. Yeah, and then I made some conclusions about how no determination is possible, and that really the kind of dating that Will Duffy suggests that is to be done here doesn't really work that way. But yeah, either way, that would be it, I think, for this stream. I need to really get cracking now, because I have an extremely stressful day tomorrow. And the day after tomorrow, so on Tuesday, I will also have an extremely stressful day, and I'm not looking forward to it. I've had an extremely stressful last week, so but I thought I'd stream no less. Either way, so what do I have? Any? Yes, I have the last comment of the day, likely by Simulacrum, who said, "Great stream." Well, thank you very much. I mean, I enjoyed the details and the tensions. That you're a very unique person. Your channel deserves more attention. Well, thank you so much. I'm very happy to hear that. I hope it gets some more attention, because I think I've been stuck on 121, although it's 122 since my last stream, subscribers for months now, which I think is so weird, right? Normally, actually, we might actually look that one up very, very briefly. If you look my channel up on Social Blades, right? Yeah, come on, go away. When you look at Olaf Das Astro on Social Blade, for example, you can see the subscriber change. And when I look at that, I've gotten 1 subscriber in the last 30 days, which is an amazing number, really. Let's and when you look at I since roughly December. Since December, I think I've not gained. I've only gained 1 subscriber. It was you, Simulacrum. Well, I'm happy then that you're here. That is very, very good. Very, very nice of you. Good job there. Good job. So my weekly average in new subscribers is 0. Oh wow. Yeah. It's sad that I can total. Yes, I can show it here. I've gotten 121 subscribers. I've achieved that at the end of January, and I somehow I made it was going very much upwards, and now in the last couple of months, really, it has petered out to now coming higher than 122, which is not a problem. I'm not doing that for subscribers, not at all. I'm doing it because I think it's funny. But it is strange. I don't understand why. I almost have as much videos now as I have subscribers, and that's not a position you'd want to be in on YouTube. Regardless, thank you so much for watching. If you did participate live, thank you. If you participate in the chat, thank you even more. Thank you also to Professor Phil Bell for dropping by. And if you watch this video after the fact, the recording on YouTube, then thank you very much as well. If you enjoyed it, maybe consider hitting that subscribe button that is annoying you down there. And other than that, I hope I can stream more regularly now that my big stress will be over, hopefully this week. I hope. Yeah, good. Goodbye.